Hang on, number one, yes or no?
Yes. Oh, no, don't do it.
Sorry, let me rephrase that. Number one, good or bad?
Good.
Good. Two.
Good.
Three.
Bad.
4.
Good.
Well, let's check the answers, just the answers.
Okay, well let's see. Well, what did you get for number one?
0545.
Yes.
Number two?
2000.
2 kilowatts.
Yes.
Yeah.
Number 4?
05025.
We didn't do it. We didn't skip.
Okay, well hang on, just if you watch the video you can hear the answer for later. What is it? 0.
025.
Give it to me in millijoules, your favourite. 25 millijoules. What was that? Number 4. Number 5?
1541. I don't know. That's it.
What is the voltage, is it? So you use the formula, this W equals a half CV squared. You know the W?
Yeah.
You know the C?
Yeah.
What was the C?
Yeah.
2, good.
V.
And the V is what you want. Good, yeah, that's right, 1.41. And then 6? 0.435 ohms. Okay, so 1, 2, 4, 5 and 6 look okay. Number 3 is a bit sneaky, it seems. Let's have a look at 3 then. So, we know the speed of the car is 20 meters per second. The force is 5 kilonewtons. And the voltage of the battery in the car? 276 volts. Yes?
Yes.
And we would like to know the resistance.
Yeah.
Okay. Let's see what we can do. So, we know voltage, we know force, and we know speed. I think we'll go with power to start with. So, P equals IV. But I want resistance. I don't really want the I in there, because I know the V. I'm happy with the V.
Really? That's it?
No, we're not. No, not even close. So what can I replace the I with if I have my triangle?
VO1.
Yeah, so P equals V squared over R. So that means R equals V squared over P. So, R equals V squared over P. We have the V, so we're happy, voltage, but we don't have the power. What's another formula for power? Huh? No, something more basic. Huh? Yeah, work over time. What's the formula for work? Basic. What is distance divided by time? Speed. So it is 276 squared over 5,000 times 20. How'd you like that? I can hear your amazement.
So I can't use half MV squared.
No, you can. No, of course you can.
You don't know and you can't find
I
M.
can't find out.
You can tell me the mass of the car?
Exactly, he's dividing by 9.81.
Oh no. No. What's the mass of the car?
It's weight over 9.8.
Yeah, what number did you get for the mass of the car?
509.7. Which is very low.
No, because this electric car could be a Toyota Prius, it could be a Honda.
I got the same answer.
No, I know. You got, it's what we call a type 3 error. You got the right answer, but maybe for the wrong reason. Yeah. You know, Yusuf, listen. This car could be a Toyota Prius, a Honda Civic.
Yeah, but it says it needs a force of whatever, 5,000 to move.
At 20 meters per second. Yeah.
Yes.
I don't okay, maybe there is enough information here to get the mass. I think that'd be pretty cool if there was.
I'm proving my point, and I also got the same answer. It's hard to get,
You know, maybe you could get the mass, but
Not over the 9.81.
with 9.81.
hang on. Let's see. Now I'm curious to see if we can get the mass. The work done is equal to
5K.
the kinetic energy. Yeah.
And work is also equal to power.
No, work
No,
is
it's
equal to
not.
power over time.
Yeah.
You don't have the time.
Yeah.
So you can't use time. You have to use speed.
Yeah.
This can't be a control.
You can't find the mass if you use half mv squared because you know the v. You'll get the mass.
You got the same answer for resistance.
Yes, 0.76.
But maybe the other variables that you found within your answer to get here are not right. You know what I mean? No, you don't believe me. Okay, that doesn't matter. It doesn't matter.
If you do half mv squared to find the m, this is what you get. Using KE as 5,000 because work equals energy.
Yeah. Okay. I'm happy you got the right answer. I remain unconvinced about the method you use.
So if he used it for another question, would it be wrong?
If he's extremely lucky, he'll be right again.
No.
This isn't good. I'm telling you, I'm not that lucky.
It's possible the way he's doing it is working, but for a reason that's wrong.
So would they mark you down in the exam if you go down?
Yes, as the method is not correct, even though it produces the right answer. I know, it seems like that's unfair, but I perhaps could make a change in the question that would make that method you use that works for this problem not work in my problem. You know?
Why don't we change the
Yes.
mass, the weight, the force, and try it?
No. What I mean is not change the numbers. I feel like if I change the numbers, your method would still give the right answer. I could make a small change to the problem setup. That would mean your method now doesn't work. You know. So no, I do believe that change the numbers here would not affect me and you getting the same answer. But I don't think your method is quite right. So it'll work here, but for the wrong reason, and would not work if I slightly change the problem. I think.
Can we solve this by finding Q?
Q?
Yeah, the charge.
Q equals,
W over V.
do we know the W?
Yeah, what?
And we know the V?
Yeah,
So you got the Q,
yes.
and then how would you get the R from that?
I don't know. That's what I'm asking. Is it possible to solve it with Q?
No, well, to get the R, you need to be looking at the V and the I, and the I is QT. What? Leave me, please. I wouldn't say it's impossible, because having the Q, but then you would need to know the time.
Or this,
I think for what information you're given in this question, it might not be possible. The time is missing here. If I knew the time, then a lot of things open up. I could do it the way you're saying it. I could confidently get the mass, but we're not given the time here, so I feel like this is the only way.
But why can't you get the mass using like the weight divided by 9.81?
Equal what?
Mass. Isn't that a formula for mass?
Mass
Or weight equals 9.81 times
G.
Yes.
Yeah, but what's the weight?
That's what you're trying to find out here. Or, yeah.
You're trying to find out the mass.
The weight.
You
Yeah,
can't,
okay, so the weight is, I use the weight, the force.
but that force is horizontal.
that's what I'm saying.
Oh.
See, because
I told you so
cars,
many times when you said it's
No,
an O and I said it's not an O.
cars travel horizontally, not vertically. So, it would not be appropriate to use it vertically. Yeah. I don't know about your home country, but here they're horizontal movement. Okay, we'll have a look at the next lesson now.